The ICC Electrical Plans Examiner test is designed to evaluate an individual's expertise in reviewing electrical plans, ensuring they comply with codes and meet technical standards. The test format consists of approximately 100 multiple-choice questions, and you will have 3 hours to complete it. Content areas covered include electrical codes and standards, primarily focusing on NFPA 70, electrical theory and design, electrical construction methods, building materials and systems, and plan reading and interpretation. The difficulty level is generally considered more challenging than the ICCP Electrical Inspector exam. It demands a comprehensive grasp of the electrical code, industry standards, and the ability to analyze and interpret electrical plans effectively. To prepare for the exam, firstly, study the ICC Electrical Code, with a focus on Articles 90, 210, 220, 230, and 110. Secondly, obtain practice questions from official ICC study materials with third-party resources to familiarize yourself with the exam style and format. Thirdly, dedicate time to review plan reading, practicing the interpretation of electrical plans. Fourthly, study building systems and familiarize yourself with lighting, power distribution, and communication systems. Fifthly, consider enrolling in an ICC-accredited preparation course for structured guidance. For tips to achieve success, firstly, manage your time effectively, allocating it wisely across all questions. Secondly, read each question carefully to fully grasp its meaning before selecting an answer. Thirdly, eliminate incorrect answers to narrow down your options and improve your chances of choosing the correct one. Fourthly, if unsure about a question, make an educated guess based on your existing knowledge and experience. Finally, stay positive, maintaining a positive attitude and focusing on applying your knowledge throughout the exam. Remember that a strong understanding of the National Electrical Code, specifically NFPA 70, is crucial. Articles 90, 210, 220, 230, and 110 are particularly important. Article 90 covers the introduction to the code, outlining its purpose, scope, and enforcement. It establishes the code as a set of requirements for electrical installations intended to safeguard people and property from hazards arising from the use of electricity. Understanding the scope of the code is essential, as it defines the types of installations and equipment that fall under its jurisdiction. Article 210 pertains to branch circuits, which are the circuits that supply power to outlets, lighting, and appliances. It covers various aspects of branch circuit design and installation, including the number and type of branch circuits required, the ampacity of conductors, and the overcurrent protection requirements. Key topics include general provisions for branch circuits, multi-wire branch circuits, permissible loads, and conductor sizing. Article 220 deals with feeder and service calculations, which are used to determine the appropriate size of conductors and overcurrent protection for electrical systems. It provides methods for calculating the load on a feeder or service, taking into account factors such as the type of occupancy, the connected load, and the demand factors. Understanding these calculations is essential for ensuring that the electrical system is adequately sized to handle the expected load. Article 230 covers services, which are the conductors and equipment used to deliver electricity from the serving utility to the premises wiring system. It addresses topics such as service entrances, service conductors, overcurrent protection, and grounding requirements. Compliance with Article 230 is crucial for ensuring the safe and reliable delivery of electricity to the building. Article 110 provides general requirements for electrical installations, covering topics such as wiring methods, equipment installation, and working space around electrical equipment. It emphasizes the importance of proper workmanship and the use of approved materials and equipment. Understanding these general requirements is essential for ensuring that electrical installations are safe and compliant with the code. The ability to accurately read and interpret electrical plans is essential for the ICC Electrical Plans Examiner test. Electrical plans are technical drawings that depict the layout of electrical systems in a building or structure. They provide detailed information about the location of electrical equipment, wiring, and other components. Plan reading involves understanding the symbols, abbreviations, and conventions used in electrical plans. Symbols are used to represent different types of electrical equipment, such as outlets, switches, lighting fixtures, and panel boards. Abbreviations are used to shorten commonly used terms, such as volts, amps, and watts. Conventions are used to indicate the size and type of conductors, the routing of wiring, and other important details. To effectively read and interpret electrical plans, firstly, familiarize yourself with common electrical symbols and abbreviations. Secondly, pay attention to the scale of the drawing and use it to estimate distances and dimensions. Thirdly, trace the path of wiring to understand how different components are connected. Fourthly, identify the type and size of conductors used in the system. Fifthly, locate and interpret notes and specifications provided on the plans. Understanding electrical theory and design principles is also crucial for the ICC Electrical Plans Examiner test. Electrical theory provides the foundation for understanding how electricity works and how electrical circuits function. Key concepts include voltage, current, resistance, power, and Ohm's law. Voltage is the electrical potential difference between 2 points in a circuit measured in volts. Current is the flow of electric charge through a circuit, measured in amps. Resistance is the opposition to the flow of current, measured in ohms. Power is the rate at which electrical energy is transferred, measured in watts. Ohm's law states that the voltage across a resistor is equal to the current through the resistor multiplied by its resistance. This relationship is expressed by the equation volts equals amps times ohms. Understanding these basic concepts is essential for analyzing electrical circuits and troubleshooting problems. Electrical design involves the process of planning and designing electrical systems to meet the needs of a particular building or structure. It includes determining the appropriate size and type of conductors, selecting overcurrent protection devices, and designing grounding systems. Key considerations in electrical design include safety, reliability, and energy efficiency. Proper electrical design ensures that the electrical system can safely handle the expected load, provide reliable power to all parts of the building, and minimize energy consumption. Building systems are integrated networks of components and equipment that work together to provide essential services in a building. Examples of building systems include lighting systems, power distribution systems, communication systems, fire alarm systems, and security systems. Understanding how these systems function and interact is essential for the ICC Electrical Plans Examiner test. Lighting systems provide illumination for the building, enabling occupants to see and perform tasks safely and comfortably. They consist of lighting fixtures, lamps, ballasts, and controls. Power distribution systems deliver electrical power from the service entrance to various parts of the building. They include panel boards, circuit breakers, transformers, and conductors. Communication systems enable communication between occupants and with the outside world. They include telephone systems, data networks, and public address systems. Fire alarm systems detect and alert occupants to the presence of a fire. They include smoke detectors, heat detectors, alarm panels, and notification devices. Security systems protect the building from unauthorized access and theft. They include access control systems, surveillance cameras, and alarm systems. Familiarity with different types of building systems is crucial for the ICC Electrical Plans Examiner test. Electrical construction methods refer to the techniques and procedures used to install electrical wiring and equipment to a building or structure. They include wiring methods, conduit installation, cable installation, and equipment mounting. Wiring methods describe the types of wiring systems used in electrical installations, such as rigid metal conduit, electrical metallic tubing, flexible metal conduit, and non-metallic sheath cable. Conduit installation involves the process of installing rigid metal conduit or electrical metallic tubing to protect electrical conductors. Cable installation involves the process of installing non-metallic sheath cable or armored cable to carry electrical current. Equipment mounting involves the process of installing electrical equipment, such as power boards, lighting fixtures, and receptacles, securely and safely. Familiarity with different electrical construction methods is crucial for the ICC Electrical Plans Examiner test. The National Electrical Code, NFPA 70, is a widely adopted standard for the safe installation of electrical wiring and equipment in the United States. It is updated every 3 years by the National Fire Protection Association. The NEC provides detailed requirements for electrical installations, covering topics such as wiring methods, overcurrent protection, grounding, and equipment installation. Compliance with the NEC is essential for ensuring the safety of people and property. The NEC is organized into chapters, articles, and sections. Chapters provide a broad overview of different areas of electrical installations. Articles cover specific topics within each chapter. Sections provide detailed requirements for each topic. To effectively use the NEC, firstly, familiarize yourself with its organization and layout. Secondly, use the index to quickly locate specific requirements. Thirdly, carefully read and understand the requirements before applying them to an electrical installation. Fourthly, consult with qualified electrical professionals if you have any questions or concerns. The NEC contains numerous tables and examples that provide additional guidance and clarification. These tables and examples are an important resource for electrical professionals. For example, NEC Table 310.15b16 provides ampacity ratings for insulated conductors. These ampacity ratings are used to determine the appropriate size of conductors for different electrical loads. NEC Chapter 9 provides examples of how to calculate the load on a feeder service. These examples are helpful for understanding the calculations required by Article 220. The ICC Electrical Plans Examiner test requires a thorough understanding of the NEC. Be sure to study the code carefully and practice applying its requirements to different electrical installations. Successfully passing the ICC Electrical Plans Examiner test can significantly enhance the credentials and career prospects. Firstly, it demonstrates a high level of competence in electrical plan review. Secondly, it enhances credibility with employers and clients. Thirdly, it expands job opportunities in the construction industry. Fourthly, it increases earning potential and promotes professional growth. Preparation is crucial to successfully passing the ICC Electrical Plans Examiner test. Start early, gather study materials, and allocate sufficient time for review. Focus on understanding the underlying principles of electrical theory and design, rather than simply memorizing facts and figures. Practice reading and interpreting electrical plans to develop your skills in this area. Attend a preparation course to receive structured guidance and support from experienced instructors. By following these tips, you can increase your chances of success in the ICC Electrical Plans Examiner test and advance your career in the electrical field. Consider the differences between the roles of an electrical inspector and a plans examiner. An electrical inspector is primarily responsible for inspecting electrical installations to ensure compliance with codes and standards. They visit job sites, review electrical work, and identify any deficiencies or violations. A plans examiner, on the other hand, is primarily responsible for reviewing electrical plans to ensure that they meet code requirements before construction begins. They analyze plans, identify potential problems, and provide feedback to designers and contractors. While both roles require a thorough understanding of the NEC and other relevant codes, they involve different skills and responsibilities. An electrical inspector needs strong field experience and the ability to identify code violations in real-world situations. A plans examiner needs strong analytical skills and the ability to interpret technical drawings and specifications. The ICC Electrical Plans Examiner test assesses the knowledge and skills required for the plans examiner role. It focuses on topics such as plan reading, electrical theory, and code compliance. While experience as an electrical inspector can be helpful in preparing for the test, it is important to also focus on developing the specific skills required for plan review. Consider the importance of continuing education in the electrical field. The electrical industry is constantly evolving, with new technologies, materials, and codes being introduced regularly. Continuing education is essential for electrical professionals to stay up to date with these changes and maintain their competence. There are many opportunities for continuing education in the electrical field, including courses, seminars, and conferences. These opportunities can help electrical professionals learn about new technologies, improve their skills, and earn continuing education credits. Continuing education is particularly important for electrical inspectors and plans examiners who are responsible for enforcing codes and standards. By staying up to date with the latest changes, they can ensure that electrical installations are safe and compliant. The ICC offers a variety of continuing education programs for electrical professionals. These programs cover topics such as the NEC, electrical safety, and plan review. Completing these programs can help electrical professionals maintain their ICC certifications and advance their careers. Remember that thorough preparation is the key to success on the ICC Electrical Plans Examiner test. Start early, gather study materials, and allocate sufficient time for review. Focus on understanding the underlying principles of electrical theory and design, and practice reading and interpreting electrical plans. Consider attending a preparation course to receive structured guidance and support. By following these tips, you can increase your chances of success on the test and achieve your professional goals.